So for this example, we have this word problem. Now, keep in mind that word problems are not a mystery. All information is supplied. We just have to be able to assemble the information into a formative equation to help answer it. This example also has an illustration with it, and you can see it right here. But you can certainly draw or sketch one of your own if it means it'll help clarify what is being stated. I certainly do encourage that. But let's just read through this. It says, Gail has a rectangular backyard that is 30 feet wide by 40 feet long. She is designing a floral garden in the middle of her yard, which will have a grass border of uniform width around the garden. Gail has 264 square feet of grass. Given these dimensions, how wide of a border can Gail make? So this graphic here, this illustration here, represents her backyard. And you can see that her backyard is 40 feet in length here and 30 feet wide. And she's going to put right in the middle of it this garden, this floral garden. So what we need to do is we need to find out how big of a border can go around this. So we do know that the border is 264 square feet. But it could be of a lot of different sizes as far as the width of its border goes. We need to know specifically so that we would have enough to go on the outside here. So you can imagine we have this backyard and we're going to plop this floral garden right in the middle of it. So this looks like a picture frame around here, right? So if I knew what the area was of the backyard and I'm just going to poke a hole in it with this floral garden, that'll give me what's remaining over here. So maybe we'll do that. So the first thing we'll do is we'll figure out what is the area of the backyard. And since it's a 30 by 40 yard, to be able to find the area, we just multiply 30 by 40. 30 times 40, that's how we find out the area of a rectangle. 30 by 40, that's 1,200 square feet. I'm just going to put it right here. So the entire backyard is 1,200 square feet. Now, one thing we don't know about this garden here is we don't know specifically what the square footage is. But we do know what the dimensions are in relationship to the yard as a whole. So if this is 40 feet right here, then the length of the yard, the garden, I should say, is going to be 40 feet. But then we have to subtract out the width of the border here, which we don't know, and the width of the border here. So we're just going to label the width of the border X. So the width of the garden, or the length of the garden here, is going to be 40 minus 2x. 40, take out an x on this end, take out an x on this end, that's what we have here. We do the same for the width here. This is 30, we subtract out x and subtract out x again, keeping in mind that it's the same width all the way around. So this is going to be 30 minus 2x. Now similarly that we did for the whole backyard, to find the area of the garden, we just multiply the length times the width. So if we went 30 minus 2x and multiply that to 40 minus 2x, and you could see we have these two binomials. We multiply them together, and that's going to give us an illustration of the size of the garden. And we're going to go ahead and we'll just use FOIL in order to multiply this together. So 30 times 40, that'll give us 1,200. 30 times negative 2x, that's negative 60x. Negative 2x times 40, that's negative 80x. And negative 2x times negative 2x, that's positive 4x squared. So here, it turns into our quadratic, which is the whole point of this exercise here. So this is 4x squared minus 140x plus 1,200. So this represents the area of the garden. So if I subtract out the area of the garden from the whole backyard, then I have what's left over, which is the border. So we'll do that. So the area of the backyard, that's 1,200 square feet. So 1,200, and I'm going to subtract out the garden, which is this, represented by this. So we'll subtract out, and watch what I do. Subtract out 4x squared minus 140x plus 1,200. Here is the backyard. Subtract out the floral garden. See it? So this is then 1200. We'll distribute this negative, minus 4x squared. Negative times a negative, so this becomes positive 140x minus 1200. So this winds up being negative 4x squared plus 140x, and the 1200 minus the 1200 cancel each other. So this quadratic expression here represents this border. And what do we know about the border? We also know that the border from up here is 264 square feet. So if this is the border, and this also represents the border, then they must be equal to each other. And look at that, we have a full quadratic equation. If we write this in standard form, then we could go ahead and solve for x. So we'll write this as negative 4x squared plus 140x minus 264. That's equal to 0. We now have it in standard form. And if we carefully look, we can see that we can factor out a negative 4 from each term. So if I factor out negative 4, this becomes x squared minus 35x plus 66. That's equal to 0. So then all I really have to do is factor this portion of the quadratic equation. And we can use the quadratic formula, but I don't think it's necessary. Don't forget that we have to come up with two values. When multiplied together will give us 66, and when added together will give us negative 35. Now I know that both of them have to be negative because when I add them together, I got to come up with a negative result. So this is going to be x minus, and that's going to be equal to 0. And if you think about it, it's got to be 2 and 33. Negative 2 times negative 33 is positive 66. And negative 2 minus 33 is negative 35. Set each one of the binomials to 0. That's the zero product rule. X minus 2 is equal to 0. X has got to be 2. And x minus 33 is equal to 0. Then x has got to be 33. So x is going to represent the width of the border. Now, it wouldn't be 33 because having a border that is 33 feet wide is wider than the entire yard. So it's got to be 2. So it's got to be a 2-foot border that would go all the way around. So the solution here is a 2-foot border. And there we go.